In this video, I want to share with you how to multiply fractions. We're first going to do this by drawing out models and then showing you how multiplication works. Then I'd like to share with you a pattern that you might be seeing when we're doing these problems. And finally, I want to review different kinds of fractions. Let's go ahead and begin with a fraction multiplication problem. And I'm going to write it. I'm also using graph paper. If you have graph paper, that might be helpful for you when you're taking your notes. You can draw out the pictures, or you could just use regular paper and then just draw some pictures alongside with your notes. So for this first problem, we're going to have 1/2 times 1/4. Now another way to think of this times is to say 1/2 of 1/4. So basically we have 1/4 and we're going to take 1/2 of it. Okay? And in drawing pictures to model this problem, I'm going to go ahead and draw 1/4 in a drawing. So I'm just going to draw like a bar. And I'm going to need 4 equal parts. Each part is worth 1/4. Okay? And if I have 1/4, that means one part is shaded. Okay? Now, I want to take 1/2 of that 1/4. So what I'm going to do is draw a line through my bar. Okay? So the top half of the bar represents 1/2 of the whole bar. Okay? Now I'm going to take, since this whole thing was 1/4, half of that is only going to include this top part here. Okay? So I have 1, but now since I've cut it in half, I have 8 equal parts. So 1/2 of 1/4 is going to be 1/8. Let's go ahead and do a few more, because I know this could be kind of confusing to grasp. Let's do another 1/2 times 3/5. So we're going to take 1/2 of this number here. Let me go ahead and draw a bar that is 5 long. And I'm going to make 5 equal parts. Okay? And I want to shade in 3 of those 5. 3 out of the 5 are going to be shaded in. Now, because I'm going to cut this in half, I'm just drawing a line through it. And I'm only going to look at half of it. So I'm going to pick the top. On the top there are 3 parts that are shaded. And I'm just kind of drawing a circle just to kind of shade it again. So we've got 3 out of 3, 4, 5, 6, 7, 8, 9, 10. Because now I have 10 boxes, 10 equal parts. So 1/2 times 3/5 is going to equal 3/10. Let's try a few more and then we'll look at some patterns. Now we have 1/4 times 3/4. 1/4 times 3/4. So that means I want to take 1/4 of 3/4. So first I want to represent the 3/4. I'm going to go ahead and make this a little larger so I can show, so my model can show what I'm doing. So I've got 4 equal parts, and I'm going to shade 3 of those parts. Each part is worth 1/4. Now I'm going to break this up into 4 equal parts. And I could draw my lines this way, but I'm going to go ahead and go this way just to make it a little easier. This would be half, and then half of a half is a fourth. So now I have 4 equal columns. Okay, see, originally I had 4 rows, and I shaded 3 of those rows, but now I broke up into 4 columns. Okay. Now I'm only going to circle 1/4. So if I look at this side here, anything to the left of this line, I'm going to shade my previously shaded parts. Okay, so now I have 3, but how many squares do I have? It looks like I have 4, 8, 12, 16. So now 1/4 of 3/4 is going to give us 3/16. Let's do one more with the model. In this model, we will have 3/4 times 2/3. Okay, so I want to draw a picture to represent 2/3. In this one, I'm going to represent the thirds in columns, and you could have done rows. You could have made a longer and a shorter in the width, but that's fine. So 2/3 is going to be shaded in. But now I want to break up this model into fourths. Okay, and then I'm just going to shade 3 parts of those fourths. So here's a half, here's a fourth, and a fourth. So now I have 4 equal parts, and I'm going to shade 3 of the rows that are shaded, of those shaded parts. So here's 1 row, 2 rows, 3 rows. So now we have 2, 4, 6, so 6 shaded parts out of 12, because we have 3, 6, 9, 12 all together. So this fraction is going to be 6/12. Now let's go ahead and look at some patterns. I'm going to go back up here and rewrite these fractions with the answers. So in this problem, we found that 1/2 times 1/4 equals 1/8. In the second problem, we had 1/2 times 3/5, and that equaled 3/10. In this third one, 1/4 times 3/4, and that equaled 3/16. And in the last model, we had 3/4 times 2/3, and that gave us 6/12. Now hopefully you're seeing a pattern here. I'm going to go back, and just to be really explicit, if you look at our numerators, when we multiply them across, 1 times 1, so here we go, 1 times 1, and 2 times 4, we get 1/8. Okay, so we're multiplying the numerators together, we get our answer numerator, and when we multiply the denominators together, we get the answer, or the product of that multiplication problem. And that's going to be the same for all of these. 1 times 3 is 3, 2 times 5 is 10. 1 times 3 is 3, 4 times 4 is 16. And this last one, 3 times 2 is 6, and 4 times 3 is 12. Now let's do some problems without the models. Let me write some down for you. Here we have 3/8 times 5/7. Now I'm not going to draw a picture, but we're going to go ahead and follow the pattern that we saw. And first I'm going to show you kind of the longhand of what's going on, but then we're going to skip a step. What's happening here is we're multiplying the 3 by the 5. 3 times 5 is going to give us the 15 on top. That's the numerator. 8 times 7, that's going to give us 56, I believe. So we've got 3/8 times 5/7 is going to give us the 15/56. Now, there's a reason why we don't want to draw a picture for every one, because if you're dividing 5/7 into 8s, that's a lot of really small squares, and then you're going to be spending a lot of time counting up the squares to 56. So it's good that we kind of graduate from drawing pictures to just working with numbers. Let's do some more examples. Here we have 3/10 times 5/10. I'm going to go ahead and write out the long way of what's happening. But in our next problem, we're going to skip this step. So I just rewrote. We're multiplying 3 by 5 and 10 by 10. 3 times 5 is 15. 10 times 10 is 100. In this next problem, let's skip this part. We can try to do this part in our head. Here we have 2/3 times 7/9. Well, 2 times 7 is 14, and 3 times 9 is 27. One more is 5/6 times 2/3. Again, 5 times 2 is 10. 6 times 3 is 18. Now, before we move on, I want to share with you some names of fractions. Whenever we have a fraction in which the numerator is smaller than the denominator, like in this one here, 5/6, the numerator is less than the denominator, this is called a proper fraction. So this is when the numerator is smaller than the denominator. Notice that in all the problems we just did, we were working with proper fractions. 1/2, that's proper. 1/4, our answer is also a proper fraction. Same with this one, 1/2, 3/5, 3/10. Those are all proper fractions. In fact, all of the fractions that we just did in this video so far have been proper fractions. The other type of fraction I want to talk about is called improper fraction. There are two conditions that represent an improper fraction. The first is when the numerator is larger than the denominator. An example of this would be 5/3 or 7/2 or 27/13. In all of these cases, the numerator is larger than the denominator. Another condition is when the numerator is the same size or is the same as the denominator. An example would be 3/3 or 17/17 or 2/2. The numerator and the denominator are the same numbers. Now, in a previous video, we talked about this. When the numerator is the same as the denominator, the answer is going to be 1, because 2 divided by 2 is 1, just as 17 divided by 17 is going to be equal to 1. Similar to 3 divided by 3, that's also 1. Even though these are fractions, they're also division problems. Okay, so that's a little bit about improper fractions.